In this video, we will learn how to convolve the two time limited signal x of t and h of t. X of t is shown in the first figure. It's x of t, which is time limited to 0 to capital T, and its mathematical description is given here. The signal is 1 between 0 to capital T, and it is 0 otherwise it is 0. Okay, similarly the h of t is given in this figure, okay, and it's time limited to 2 capital T, and it's mathematically described here. H of t is actually equal to t for 0 to 2t, so you can see it from the figure also. From 0 to 2t it is actually equal to t, and it is 0 otherwise. So let's try to convolve this, and we follow the convolution step. And as a first step, what we do, we will see the convolution graphically as well as mathematically. So in step number 1, let's change the variable t to tau. So we change the variable. All right, change the variable, and we introduce another variable tau. Change the variable t to tau. So if we change the variable x of tau, we will have x of tau and h of tau. Basically, changing the variable is just replacing t by tau, and it just does not change the shape or the range of these signals. So I will just change it over here. Instead of t, I will write tau. Okay, nothing else, no change in. So let me change these variables. X of tau would look like this. It's tau axis now, tau axis, and h of tau is the same. Now here we have the definition for we can just change. The definition is same, but we just, instead of t, we are using tau variable now. So we have tau, x of tau here, and it appears here also. So let me write tau here, and similarly we can replace a t and a t here, and we will replace it by tau. Okay, so these are the changes which we can make in the graphical representation and the mathematical representation of these signals, x of tau, h of tau. Now in the next step, we have to because if you see the final the y of t, the final form, the mathematical description of y of t is from minus infinity to plus infinity. You have x of tau and h of t minus tau d tau. So we have to see, we have to evaluate this integral for convolution. So as a first step, we just change the variables and we get these expressions. So let me see the h of minus tau. So if I say in the next step, step number 2, I'll just have the time reversed version of h of tau, one of the signal. If you see over here in this expression, we have the time reverse version, h of minus tau, and then I will apply the shift also. So the time reverse version in step number 2. So we have step number 2, and find h of minus tau. Okay, h of minus tau. So when we replace h of tau by h of minus tau, you can see it's the time reverse version, and the signal would look like, I will draw it here on the same axis, tau axis. So h of minus tau will be from 0 to minus 2 tau, and this is going to be mirror image here you get a mirror image of this signal, it should look like this. Okay, it should look like this one. So let me draw it neatly, and it would be a point. Oh, it should look like this. Okay, so the same point, the height is same, but it is just the mirror image of the signal h of tau. So this one is basically h of minus tau. As we see h of minus tau, the same you can replace. See, your h of tau, the equation for h of tau was tau. Okay, for tau between 0 to 2t. Now it's h of minus tau. Now you can see, replace h. This is basically h of minus tau. Now tau replaced by minus tau. So it is minus tau, and your range is also tau is minus tau. So the range basically, if I replace here 0 minus tau up to 2t and just modify this range, it would be same as for the tau axis. It would be for tau minus 2t. Now just multiplying throughout with minus 2t, so you will get tau less than or equal to minus 2t up to 0. You can see this in the from the figure also. Okay, you can see the same from the figure also. So our range is not this one. You can see in the figure here, it's quite clear. The signal now exists from minus 2t up to 0. So minus 2 times capital T up to 0. And this is the equation of the signal, which is important. It has to be used in the convolutional integral. Now in step number 3, we just give a shift to this shifted version, step number 3, because we have to drag the signal, shift, apply time shift. All right, time shift. So time shifting is actually we just want to find out the variable plus t naught. Okay, so it's, we have a variable h of minus tau and plus t. Let's say we are using t, so minus tau plus t, or simply you can say h of t minus tau, h of t minus tau. This is the equation of the impulse response which will be used in the integral. Okay, and if, just keep this in mind, when you get h of minus tau, if you apply h of minus tau, already we have h of minus tau is here. Let me redraw h of minus tau. It's here up to minus 2 tau to 0, and this is to capital T. So minus 2t up to 0, the signal is available. Now if this t is negative, okay, if this t is negative, what happens to the graph? If the t is negative, this further moves here towards the left side. Okay, if t is negative, then h of minus tau moves towards the left side. Keep this in mind, this is the tau axis, so it is t, and this point here is t minus 2t. So it moves from here t units towards the left if t is negative, and if it is positive, similarly it will move t units towards the right from 0. So this point here is t, this point here is t minus tau, and we know the peak value, which is 2t. Now let's look at these the product in step number 3. Let's see the product in step 4. Step number 4, let's see the product of the two signal x of tau and h of t minus tau. Now the product would look like this. Let me draw the product here towards the let me draw the product here we are on the tau axis, and we are on the tau axis, and let me draw both on the same axis. I have a signal which is x of tau from 0 to capital T. Okay, this is unity, and another signal which is h of t minus tau, which is somewhere. Okay, h of t minus tau actually is here. Okay, so it's from minus 2t up to 0. From minus 2t up to 0, it is the signal is available, and keep this in mind, this is 2 times capital T. Now if we apply the time shift, now the t is 0 here. For this specific case, you should keep this in mind, that for this specific case, when we see this signal, this is actually h of t minus tau, but t is assumed to be 0. There is no negative or its value is 0. So the signal is just the time reversed version of h of tau. Okay, it's the time reversed version of h of tau. Just keep this in mind. Now if we apply if you want to see this product, okay, we want to see this product, this one. We want to see this product. So x of tau is here. We already have x of tau available, which is drawn in green. Okay, and h of t minus tau is drawn in black, which is available here. The product, you can see, as long as t is less than 0, there is no product of the product is actually 0. The product of x of tau and h of t minus tau is 0. Now when t becomes slightly greater than 0, what happens? When t becomes slightly greater than 0, this signal can be, I just move the same signal slightly forward. Okay, so I move it slightly forward, and if I move slightly forward, it's just like that. See, let me move it forward, and we can plot it like this. See, this point is t, which is now a positive value. This point is still t minus 2 times capital T. It's moved t units towards the right. Okay, and the peak value is still the same. Now what's the if you see the product, we have the product only from 0 to t. Okay, from 0 to t, and we are integrating. We have to integrate this product, because for the convolution, if you see, for the interval when t is less than 0, for t less than 0, our y of t is actually 0, because there is no product. And when the next interval, so we have first interval was t less than 0, which implies that our signal y of t is actually equal to 0. In the next interval, the second interval, we can take second interval, and you can assume that t is slightly greater than 0, but it is less than capital T. So our next interval, what we can write, that our next interval is actually, instead of this, we will write t is between t is less than capital T, but it is greater than or equal to 0. Okay, greater than or equal to 0. So for this interval, we can evaluate the convolutional integral for this interval, plus infinity to minus infinity x of tau and h of t minus tau, h of t minus tau d tau. We solve this integral. Now we can see the product from the figure. Okay, this product is available here only. This is the product. Okay, 1 multiplied by t. This function is t. Okay, this function h of h of t minus tau. So 1 multiplied by h of t minus tau, we have to evaluate. So this we can write it here, that it is equal to, from the limits of integral would be from 0 to, the lower limit is not from infinity, because from minus infinity to 0 the product is 0. From 0 to t the product is non-zero. 0 to t the product is non-zero, and it is equal to x of tau. X of tau is actually equal to 1, and h of t minus tau. H of t minus tau, and we can, instead of writing h of t minus tau, let's write its equation, because this is what we have to integrate. So the equation is the equation of h of t minus tau is actually t minus tau d tau. Okay, we have found this equation in above. This is the equation which we have to use. H of t minus no, not this one actually, h of t minus tau. This is what we are using. So we have to evaluate this integral. So let's try to find out the integration for this range. When t is between 0 and capital T, we can find our y of t. It will be equal to, keep in mind the variable is tau, so we can split it into two integral, 0 to t, and minus the second integral is tau d tau. And this can be evaluated. We can write it as t tau 0 to t, and the other one is tau square over 2 0 to t. Now if you apply this limit, you have t, and apply the limit t minus 0 and minus half, apply the limit t square minus 0, and we can write it as t square minus t square over 2, and the answer is half t square. Okay, so y of t in this range, y of t is, when t is greater than 0 and less than capital T, y of t is half t square. Now let's try to find out the value when it is, now it can be dragged. We already had, we found the integral here. Now let's move it further when it crosses the capital T. Okay, so we can just redraw this signal, just drag it further. So if we drag this, now let me mention the point 2t also here. This is a point 2t. Now we find, we assume that our t is greater than this value. Okay, our t is greater than, it's between, it is in this range, greater than capital T, less than small t. Okay, this point is still the same, t minus 2t, but we are now the limit of integral. Now you concentrate on the product of this x of tau and h of t minus tau. The product will be non-zero from 0 to t, because from 0 to t you can see the signal is the our x of tau is unity, and the function is available here, which is h of t minus tau. Okay, so these two in the rest, in this range and in this range, the product would be 0, because the one of the function is 0. X of tau is actually 0. So the limits of the integral will be from 0 to capital T. So let's try this. Let's try evaluate y of t for the range of t between for the range of t, not for the range of t greater than capital T and less than 2t, okay, for this range. So our integral, the limits of our integral is from 0 to capital T, and it's the same x of tau, okay. We have x of tau h of t minus tau d tau. So we can evaluate this integral 0 to capital T. X of tau is unity, h of t minus tau we already have found the equation for this one. And if we see here, this is integrating. Again, we split it into two integrals, and we have tau d tau from 0 to capital T, okay. So this would be t times capital T, and this would be tau square over 2, okay, tau square over 2 from 0 to capital T. So we can evaluate it, t times capital T minus tau square over 2, okay. So this is the, so we our y of t is actually equal to capital T times small t minus half of capital T square in the range of t when it is between greater than capital T and small than 2t. So it's for this range. Now we can also observe the same function. If you see the same function, let's look at the same function. Let me erase it, and if our t is greater than 2t, what would happen? Now we further drag this function, and we say that the function now it's greater than 2t. It starts from it's greater than this one, okay, this point. So let me draw it properly. Let me erase other points so that they do not mix up with our previous discussion. Let me clarify. So we have t which is greater, we have t which is greater than 2t, okay, greater than 2t. This is still t greater than 2t, this point, and this point is still t minus 2t, right? It's t minus 2t, but t is greater than 2t now, and it is greater than 2t but less than 3t. So it would be somewhere this this end would be still somewhere here, okay. So it's, we have selected another range, and this range is, now we are evaluating for t greater than 2t but less than 3t, okay, so that we have a non-zero product. And you can see the non-zero product for this range. The non-zero product is only the value, the product is now this value, okay, and this one, these two, or you can say, let me change the marker, this product is h of t minus tau up to here and here. The product is from, it means from t minus 2 up to t, the product is available only in this range, okay, in this range. For the rest of the time the product is 0 because one of the two signals is 0. So we have to integrate it from the product with the limits t minus 2 times capital T up to capital T. So our product, we have to evaluate the same integral, okay, for this range we have to evaluate the same integral in the limit t minus 2 times capital T up to capital T, x of tau h of t minus tau d tau, and this is already available, okay. X of tau is unity, and h of t minus tau, the equation is available with us, which is t minus tau d tau. Now we are actually evaluating t minus tau d tau in the limit 2 times capital T to capital T. And if we integrate this one, you can have two integrals, t d tau t minus 2t into t minus tau square over 2, and the this would be let me write it as an integral first, and then we will integrate it. Minus tau d tau in the same range, t minus 2t over capital T, and this can be simplified as t tau, and the limit would be t minus 2t capital T minus tau square, half tau square, and the limit is t minus 2t up to capital T. Now if we apply this limit, before applying the limit, let me change this sign minus to plus. It will facilitate our analysis. So I'll change it, change these limits. The lower limit will become the upper limit, and the upper limit will become the lower limit, and I'll change the sign. So I'll change this sign, and I'll change this one, the upper t minus 2t, and here I would just change this one, which is the lower limit becomes the upper limit becomes the lower limit, and I change the sign. Now let me evaluate, let me write it down here, t, and when you apply the limit, capital upper limit minus the lower limit 2t, okay, and then we have half and apply the limit. So the upper limit is t minus 2t whole square minus the lower limit, which is small t square. Okay, so let's try to evaluate this one. Now it's t, and here we can see we have 3t minus small t. Okay, and inside this one we have t square plus 4 capital T square minus 4 t times capital T minus t square. Okay, and this is 3 times t capital T minus t square. Then from here we have half, and this can be simplified inside first. So we have t square plus 4t square minus, see this one, like terms, collect the like terms. So this will be 3 times t square minus 4 times t capital T. Now we have 3 times t tau minus t square plus t square over 2 plus 3 times t square 3 over 2 t square minus 2 times t capital T. Okay, and this can be just rewrite it as now see 3 times like terms, 3 times t minus 2 times t capital T. So this will be t and capital T. We have a capital T and a small t. Now like terms, here you can see 3 minus t square minus plus t square over 2, so minus 1 over 2 t square, and then you have 3 over 2 capital T square. There is no other term for this one, 3 over 2 capital T square. So your y of t is actually this one. This is your y of t, and for the range this is greater than this is greater than t. This is greater than what was the range? Greater than 2t, but less than 3 times capital T. So this is the range, and if we observe the same function for t greater than 2t, again there would be no overlap, and our product, our y of t, becomes 0 for t greater than for t greater than 3 actually for t greater than 3t, not 2t. Just keep this in mind. Should be, because for 2t we already found, so make this correction. For t greater than 3t, if we have t greater than 3t, okay, then there would be no overlap. Okay, there is no overlap for t greater than 3, and your y of t becomes 0. You can plot this also. You just to summarize all these results. We have y of t equal to 0 when t is less than 0, and then we have y of t is actually equal to half t square when t is between 0 and capital T, and our y of t is actually equal to minus half t square plus capital T times t plus 3 over 2 capital T square when your t is between 2t to 3t. 2t to 3t. There is another interval also which we saw. I just forgot to write that one. We have another range when we discuss t between capital T and 2t, and the answer which we saw is t times capital T minus half t square. This is what we derived. So we actually have these intervals. Okay, and for t greater than 3t, the output again would be 0. So if you want to plot y of t, you can do that, y of t, using these equations. Okay, this is a non-linear equation. 0 to t is a non-linear equation, so you would have an increase, a non-linear increase from 0 to t. You can just approximate plotting would be something like this. From 0 to t there is a non-linear, it's like, see, t square, half t square, so there would be non-linearity, something like this, increasing curve. Okay, then you have another equation, and which is a linear equation. Basically it's basically a linear equation up to 2t. So you would have you expect a straight line to 2t. From here up to here, expect a straight line, and then there is again a decrease, a non-linear equation up to 3t. Okay, up to 3t, it's a non-linear equation, so there would be a decrease, and you can expect a decrease, a non-linear decrease here. For this is t, actually y of t, we are plotting y of t. So any graphic tools can graphical tool can be used for quick graphing, quickly plotting this one.